what I was going to do is I was going to use Claude AI to actually build the actual Tetris game itself. And I wanted to show exactly how a developer thinks when they're building prompts with Claude, including architectural design and so forth. So this wasn't just, just I was going to hand all the coding off. I was going to actually do some proper code review of all the Claude code that would be generated and show exactly my thinking when I prompt with Claude. So I've actually prepared the prompt, and I'm just going to just display it now and just go through it with you. So what I'm going to ask is, I said, could I write a React TypeScript application that using Tailwind? I'm going to use Tailwind and arrow functions. I don't want any sort of the old school style functions. I want the arrow functions that will do the following. And I basically gave a summary about the project. So I like to build a Tetris game. We will have 4 games displayed on the screen at once. Each one is going to be controlled by a computer player that will compete against each other. The React app will use select blocks for layout design. I like the React app to be responsive and have a Tetris arenas stacked up on top of each other when viewing on a mobile phone. Please make the Tetris arenas lay horizontally next to each other on the desktop view. So I've thought about sort of how this is going to look on the mobile and the desktop. And the React application needs to be split up in the following components. So instead of just giving some general, requirements, I'm actually telling it how it should architecturally design some of the components. So I've got the block.tsx. This file will render a single block cube for Tetris with a color. The prop color will be passed as the prop, passed to the component, as well as X and Y coordinates. That actually needs to be X and Y coordinates on a Tetris board. Since we are going to render many of these, I like to use React.memo here if possible, so that it only renders when the prop changes like X and Y coordinates. Because we're actually going to be rendering a lot of these. So, every time the child renders, we don't want to have to keep rendering all the blocks if they don't change. So I think React.memo might be useful here. We've got something called falling block.txx. And this is basically the block that's coming down, sort of thing, on the actual arena. And this will render a group of the block.tx for the one that is currently falling on the board. This is the block that is falling and not the whole board. Then we've got the actual board itself called board.txs. This component will render a whole board. It will render the falling block for the current falling block, and it will render multiple block.txs for each of the placed blocks on the board. I like to keep the line size of this file size short. So for the logic in dropping the blocks, can we put this in some sort of util method? I'll explain some of the logic below. The set timeout call to the util method should speed up as the time goes by for each second of the Tetris game, so that it gets faster and faster as time goes by. I like a prop which sets the player's name, which the component should display the player's name on the top of the board as well as the score. Then I've got a few utility classes. These might even be custom hooks and so forth. The way it should work is there will be some sort of set timeout to occur from board.txt that would call this util method on a periodic basis. That would calculate the new board state and the current block that's dropping. The actual drop itself might only happen once every 10 ticks or so. But for each tick, I like to make the computer player AI decision to make a decision about whether they want to move the block, what they want to do in that frame. I'm going to provide the API spec that will be the interface between this util class and the AI logic. The AI logic will be implemented later, but we need to build the placeholder and the API interface to call this interface. The order and the type of blocks that will be falling will be pre-decided at the start of the game. I like all AI players to have a fair chance by working with the exact same pieces as each other. We've got something called game state, and this is basically going to hold this is going to make all the decision about what blocks are going to be used for the whole game. I want some sort of centralized control here. This will be some sort of custom hook that would set up the game state in order to the blocks falling the whole game. For each block falling, we can have different shapes for different types of blocks. I like the arena in which the blocks would sit in the space of 4x4. Not all spaces in this area need to be filled with blocks. The reason is we define a fixed 4x4 area so that when the blocks turn clockwise or anti-clockwise, it's easy to work out how the blocks will rotate within its 4x4 space. Because what you need to do is you need to know where the center of this thing is, right? And we're going to be giving this to other AIs. And it needs to be very clear when they rotate it, where the actual pieces will move when they rotate it. So you got to know where the center point is in the actual block piece. So the better way to do that is just to give a 4x4 space. So I've thought about these design decisions beforehand. And that basically makes it easy for the API, because then I explain, for example, when you're turning the anti-clockwise, the block at position 0, 0, top left would move to the bottom left when turning anti-clockwise at the block position. And the block at position 3, 0, top right, would move to the top left when turning anti-clockwise, right? This makes it easier for the script implementing the AI logic to understand how it rotates. Game.tsx. This holds the component together. We will hold the 4board.tsx components for each computer player and to also take into consideration responsiveness for mobile viewing. Do not implement separate components for mobile and desktop. This has happened before, Claudia, I have to tell it. I like a component to handle both the views for mobile and desktop. Now I kind of go into the API spec. And when the block util needs to call the API to calculate how prices were moved, the following API will be used. And I've defined an interface. And the block def describes a single area space by in the 4x4 area, and if there is a block occupying at any particular part of this 4x4 area. And like the x coordinate, this one here, it describes like where that is on the board, the actual x coordinate on the board, and where the y coordinate is on the board, and whether there's actually a block at that spot. Now this block det is part of this thing called dropping piece. And this thing here is by 4x4, this multi-dimensional array. And it defines basically, you can go to any spot in that 4x4 array, because that basically makes up the area of the 4. Because remember I told you the area of this dropping block is 4x4, right? So you can go to the indexes of these, and then you can get the actual coordinate on the actual board, and you can find out whether there's actually a block there or not. So this should be all filled up by 4x4. And then we have something called the board, which is basically the whole state of the board, and that also has a multi-dimensional array of Boolean, which basically says whether there's currently a block occupying at that X and Y coordinate. And essentially, the reason why I've done this multi-array, it's actually because of improving the time complexity in the algorithm, right? An index in an array can be accessed very fast. Because basically what happens if you give it like an index of like 1 or so, it has to know how much the individual the structure takes up in memory space. But once it knows like what they call the base address of the actual where this thing starts in memory, it can work out an offset from the index to actually work out the memory address where this index actually occurs. Because what happens in memory is it's a sequential. So you've got like one block there, one block there, one block there, one block there. So knowing this, we can design the API so that the AI can work with data structures that are going to be fast, and it's going to allow it to get to the information it needs to quick. So we can cut down things like time complexity in our code. And this is things like this. Understanding things like this is the reason why developers can. This is the difference between a developer prompting and like someone like a non-technical prompting. A developer can go into fine details into the optimization of the solution of how things should be built with the AI. Game state holds the whole game state of the current AI player's board. It's multi-dimensional array. So basically what I just said. Right. And then the function will return an enum. And the enum basically just tells the game engine whether you're moving it left or right, or you're not doing anything, or you're just going to rotate it. It's defined by this. We've got like no move, which means do nothing. Move left, move right, rotate clockwise, rotate anti-clockwise. And I explain this a bit down here. And then we have this overall function which basically does it all. That it's going to be a mess. It could be implement multiple functions that are called from this function in the AI's code, but this is eventually the entry point of our API. We pass a game state at the current game state, and then we basically it returns what it wants to do. I would like some Jest React testing framework tests written for each of the components and also util classes. You might need to use some mocking, Jest mocking for some of the util classes. When the AI player has been eliminated, we keep continuing until one AI player is left, and at the end, the order of the elimination will be displayed. This is what I want to actually see who came first, second, third, and so forth. Could you also make the website, and this is kind of like a bonus thing I did, play a sound file. I'll put it as tetris.wav in the public folder of the apps that can be found by you inside the app once the game starts. So this is my prompt. And this is a detailed prompt. This is like, I think this is the difference between, let's say, like a developer prompting AI versus, someone from non-technical, because non-technical, they won't care so much about the detail. We provide, when I prompt with AI, I provide high-level design. I provide interfaces like this. And I say, what needs to happen in what class and so forth. So we can, and you can get the AI to construct the code in that manner. So that's what I do. It just helps it to be clean, helps it to be optimized and so forth. And that's the most important thing too when we generate AI, as well as, to also doing code reviews on the code and ensuring that the code that it has produced makes sense, it's meeting the requirements, and it's also optimized, and it's not going to get you into any trouble or anything like that in production and so forth. So that's why I think that while my view on AI, I think that at the end of the day, it's actually in some cases the biggest gift for developers and not for business people because it basically allows you to build something that essentially you'd have to hire a lot of developers to do in a very short period of time, and it still requires someone who's technical to be able to guide it. So now we're going to generate the code from the prompt. So I'm going to paste it in. It's going to be a huge thing, so it's going to basically be a pasted document. I'm going to use Sonnet 4.6 to generate it, and I'm just going to generate it now, and we'll enjoy the long, well, not really long at all, producing the code generation for the file. So the complex multi-file React TypeScript application. I'll create the files needed. Let me build this out systematically. So once this is done, we'll do a code review. We'll go through each of the things it's actually generated. And there'll probably be some changes and a few little fix-ups of things we have to do. If there's things that are fairly simple to do, I'll probably just manually do them myself. Otherwise, I can probably prompt again to actually help it to make those changes. And we'll see how we go with that. Yep. For the AI, and I'm just doing a bit of a code review on what it's generated. And at the bottom here, we get all the files and everything like that. I really like how it builds you like a nice README file. It's very much detailed. The project structure I like. I'll probably have like a pages folder or something if I have many pages or something like that. But other than that, it's generally in an okay structure. And it's followed my rules about the AI interface and so forth. And to implement a test as well too. So a few things that I don't like that basically are a performance issue is I'll just show you the actual AI logic, right? It actually went ahead and implemented like a basic AI function. I'm going to remove this because essentially I want the AI to be written by the different AI providers like ChatGPT and Claude and Gemini and so forth. So I'm going to have one for each one, right? And I'm just going to get rid of the example one. It's just put an example one in there at the start right now. But it's got this game state. And as I told it has to have a game state, right? And if we go to it's actually got a file called types. I'll find the file here. It should be here somewhere. It was up the top here. It's not showing down the bottom down there. That's interesting. So the types has all the basically the types of all the things I gave it and so forth. And you can see here at the top, it's got the game state, and this is basically what I define with the dropping pieces. It's got the block def and so forth. And then it's also got this thing called the board state, which has put a few extra things in, which is good. And it's got the falling piece, which this is really strange because I'm just wondering how this actually works with multiple players here too. That's another thing I've noticed as well. So I'll have to have a bit more read into the code, how it's doing it. But essentially one thing I've already noticed already is in the AI logic, with the game state object that it builds, it actually, in the block utils, it actually has this method called build game state. And it takes in like a board state and it returns the game state. And like, here's the thing though, right? So what's actually happening from a high level is it's got its own sort of like internal state that it's working with. And then when it presents that part of the state to the each of the players, essentially, and this doesn't make sense actually with this logic because it looks like it only works with one AI player. Essentially, when it presents that state to the actual AI player, right, it has to do with this code called get block defs, and it does all this transformation. Right? Why can't it just keep the state in place and have it so that it just passes the internal state, which will be written to sort of be one common state component, and it passes it from the actual internal into the actual AI API interface. Like, why does it need to do some transformation? Because that transformation is a performance bottleneck. Like, it's doing every time it's doing a tick, it will be doing like a transformation to something that's readable for the AI. But why couldn't the internal state work with that? Like I don't see why I couldn't have built the code to work from the internal to work all across the whole board, right? So if there's like if there's doing this thing every tick and so forth, then there's like you can see here like right, this is what it's doing every tick, and you've got like a for loop inside a for loop, right? You think about time complexity, it's not good, but and I know it's only like 4 by 4 rows, but it's like why can't it just work with the state already in place, and work with that. So that's one little pickle I have. Another thing I've just noticed too, I was actually just now code reviewing and just noticing it, is this falling piece state. Like I would expect that there would be one per AI players, four AI players, right? Because what you could have is you could have a falling piece going down. Like maybe what happened, I'm going to actually have a bit of a play with it and actually see how it works from the actual using it. But what should happen, as I would expect it, is that each AI player would have their own state of the falling piece as it's cooling down. This would symbolize that, that it falls down and then it places down and then it waits for all the other AI players to maybe fall down and place theirs before it moves to the next falling piece state. I think that's what it's done. And I don't really agree with that, but because I think, it's, I guess here's the thing though, right? It's the AI can do everything in one tick, right? It's not tested by reaction speed like a human is, right? So, whether it waits after each piece is full, I guess you could probably say that's still fair to do. So I can probably, if that's what it's doing, it probably still is all right. So I'm just going to have a detailed look through the code. But basically, I think, I wasn't what I was entirely expecting it to do. And even with the state, it rebuilding the state across into the AI API, I didn't agree on that either. So it's done a few things that I wouldn't have done from a performance perspective. But I'm just going to keep going through the code. So basically, it's done all the components as I told it to do. It's built like a game and so forth, the game TXX. And one good thing is that I think this is a little bit big, the file, not as small as I'd hoped, but it's probably passable in my opinion. I think files should be a little bit more smaller than this. I think this is actually kind of big for what it's, and potentially should even be broken up a little bit more. And then you've got like it's built like the board.txx, which that looks fine, I guess, to me when just briefly looking at it. I don't like. See, this is the thing. I don't like it doing all this logic inside the components. Like I like this to be like sort of like in a util class as much as possible, and keeping a lot of the component very simple and just showing like sort of the render, and then having sort of the logic sort of thing. Like if there's any complicated logic like this, for example, this is very very nesty sort of code. I'd rather this into some sort of like util class or something like that. So to keep these files small and simple, so I think it's more easy to read when the files are more simple. You can just go to what you need to go to navigate to all the util methods and so forth. So this is some of my views on the code review. I think now that the React.memo in here is probably overkill because it's got like it's just a div rendering that now. I don't know. And here's the thing too with the audience that's looking at this. Do you think, like for example, with the state that we gave it, right? The game state. I'll go up to the actual game state code and the types file, right? When we pass in the game state and we pass in the dropping piece as this block def, do you think it's actually? I guess you got to think about this from the AI's logic point of view. Like it really depends what the AI logic is going to do, right? But do you think it's easy if you just had like an array of all the different pieces, or you had this case where it tells you whether in that 4x4 block whether there's actually a block or not, or do you think it's just better to have, let's say, if the template, if the actual block is 4 pieces, this would be an array of four different blocks, and it would just have the X and Y, and there wouldn't be a has block because everything would be a block, and this would just be a single array. Like maybe that's probably. I'm just trying to think from a performance point of view, which is better because like I like the fact that this way you can basically say at this position in the actual 4x4 grid, I want to know exactly without having to iterate for the whole all the dropping pieces, right? That make up that piece, right? So this is some of the things, some of the design decisions that I'm sort of deciding which is actually better which should actually be better to do. So yeah, that's a bit about my code review for this. I think that there's probably a lot more. I'm going to have to go for it deep because it's quite a big project. But there's a few things like that it didn't have a separate dropping piece. I don't quite. I'm going to have to see what it does fully in the app because I think, to be honest, if the dropping piece, if it drops and then it waits for the other one to finish, I can probably be okay that because the AI, like it's not based on it doesn't know what the next piece is for starters, so it can't really plan ahead. I'm assuming that it won't know what the next piece is. Well, here's the thing though, right? The dropping piece, what happens when that's dropped? Will that well, actually, it doesn't make sense. Yeah, what am I saying? It doesn't make sense because this has an X and Y coordinate, right? This has an X and Y coordinate, and that would be different for each AI player based on how far that piece had dropped down. So this, I don't even understand how this works. So I'm going to have to really go through it and look at what it's done because I think some of it doesn't make sense here. So I'm going to have to see how this works from a full application. Yeah.